Look at this coding problem. Subarray division. Two children, Lily and Ron, want to share a chocolate bar. Each of their square has an integer on it. If this is a chocolate bar, then every square has an integer on it. And Lily decides to share a contiguous segment of the bar selected, such that the length of the segment matches Ron's birth month and the sum of the integers on the square is equal to his birthday. So there are three things to look at here. One is contiguous segment, birth month, birthday. Okay. So length of the segment means what? Length of the segment means in that contiguous segment how many squares are there. That will be the length of the segment. And every square will have integers on it. So when you do the sum of those integers, that sum has to be equal to birthday. And the length of the segment and the number of segment has to be equal to the birth month. And what we have to do in this problem is we have to determine how many ways she can divide the chocolate. It means how many such contiguous segments are possible, right? How many such contiguous segments are possible? Right? Like for example, if you look at this, this is the integers to every square. Okay, D is, let's say, birthday and M is the birth month. So birth month is 2 and birthday is 4. Then what you have to find out? You have to find out all such contiguous elements such that the sum of integers is going to be 4 and the length is going to be 2. Length is going to be 2 means that we will look at 2 consecutive squares in this case only. Okay, if the 2 consecutive squares, when you look at 2 consecutive squares and the sum is equal to birthday, okay, then this consecutive squares is a one of the way. Okay, or this consecutive square will serve as one such example. So Lily wants to find segments summing to Ron's birthday, D is equal to 4 with a length equaling his birth month, M is equal to 2. So in this case there are 2 segments meeting her criteria, right? What are those segments? You look at this, 2 and 2, 1 and 3 and 2. So this 2 and this 2 meets that criteria. When you look at these 2 adjacent, because we have to look into contiguous squares and M is equal to 2, so we have to look into contiguous 2 square only. So 2 and 1 do not satisfy. Okay, 1 and 3 they satisfy or not. So 1 and 3 they satisfy. 3 and 2 they do not satisfy. So you have 2 answers here, this one and this one. Okay. What are the constraints? The number of squares is going to be between 1 to 100. Okay, and every integer value that you are going to take is going to be between 1 and 5. These are the constraints that you have to be mindful of while solving. Okay, and then of course the constraint for the birthday is going to be between 1 and 31, right? And the constraint for month is going to be between 1 and 12. Okay, so n is 5 here, means that the number of squares is 5, and these are the integers on the squares, 1 2 1 3 2, 1 2 1 3 and 2. Okay, and this 3 is your birthday and this 2 is your birth month. Third line contains 2 space separated integers D and M. So birthday is 3 and birth month is 2. What does it mean? It means 3rd February. Okay, so birth month is 2, means we have to just look into the adjacent, any two adjacent. Okay, how many of them sum up to 5, sum up to 3? This one, this does not. This is because 1 plus 3 is 4, 3 plus 2 is 5. So how many ways? 2 ways. Okay, number of squares is 6, and these are the integers on each square. Your birthday is 3 and your birth month is 2, which is 3rd of February. So 1 1 1 1 1 1. So birth month is 2. You have to, so the length of your contiguous squares is going to be 2. So we will check in 2 adjacent elements only. The sum is always going to be 2. The sum is always going to be 2. It is not going to be 3 anytime. So you don't get any division. It's 0. Okay. Sample output is 0. So one is that there is only one square, which is this, means this chocolate bar is going to have only one square, and the integer on it is 4. And your birthday is 4, and birth month is also 1. So it all satisfies. You have answer 1. Now let's look into how to solve this problem. So this S is this array. It contains all the integers from the squares of chocolate bar, and you will be given D and M, where D is the birthday and M is the month. And the condition is that your contiguous square, means the contiguous segment, the size, the number of squares in that contiguous segment will be equal to M. Okay, and let's say M is equal to 2. Okay, let's take when M is equal to 2. Okay, using this element I, can you get one contiguous segment that satisfies the conditions? You get a contiguous segment of length M, and the sum of integers is equal to D. Okay, so this is what we are going to do. We are going to take for every element in this array, I am going to check whether from that element can you get a contiguous segment that satisfies the condition. Okay, so how my code would be like, it is like for int I is equal to 0, I less than n, means if n is the size of the array, I plus plus. Okay, and for every I, what I will do, I will first make sum equals to si. Okay, I will first make sum equals to si. Okay, so first I will take int count is equal to 0, because we have to calculate the number of ways we can find the contiguous segment, right? So I will put count as 0. Okay, and this sum is equal to si. For every I will first set sum to be si, and then what I will do means I will update this sum by adding the integers in a contiguous location till means m squares. So I can do, okay, 1 minute. Maybe your first element itself, maybe this itself, means this integer itself is greater than D. In that case, you don't need to go through all the contiguous squares to find out whether this contiguous square satisfies the condition or not. In the very first element itself, you get to know that no, this element cannot be a part of any contiguous segment, because the element itself is greater than D. For a efficient code, you have to take care of this situation also. So what I will do is, basically I will not use for loop and go means for all the contiguous m squares. What I will do instead is I will use a while loop. Okay, and in the while loop I will make a condition that I will go till my sum is less than D, and I is equal to, because I have to take care that I do not just go to find to update the sum to all the consecutive squares, I have to limit myself to at the maximum limit of m squares, right? So while sum is less than d and I is less than equal to I plus m minus 1. Okay, I plus m minus 1. And now how I plus m minus 1? If you don't get it, then I should not be explaining it. Means do some brain activity and find it out. Okay, listen. Let's say m is equal to 2. Okay. Now for I is equal to 0, what do you want? You want to visit two consecutive squares, right? So what are those squares indices would be? 0 and 1. Okay, 0 and 1. You want two consecutive square? The index 0 becomes one consecutive square and index 1 becomes another consecutive square. What is index 1 is? 1 is equal to what? 0 plus 2 minus 1, right? Where 2 is your number of, 2 is your birthday month, 0 is your I. Okay, so let's take I is equal to 1 now. Let me take I is equal to 1. I is equal to 1. Now the consecutive squares that I will inspect is 1 index at index 1 and at index 2, right? So whatever the value of index 1 is already updated in sum, and then so already updated in sum. I am asking I to be less than equal to I plus m minus 1. Sorry, j is less than equal to 1 minute. I am really sorry. So I have to do this also, that let me take j is equal to I plus 1. Okay, and j less than equal to I plus m minus 1. Okay, so now I have already taken si in the sum, and j has become I plus 1, which j has already become 2. So now I is 1. 1 plus 2 minus 1 is 1 plus 1 is 2. It is less than equal to, so it will go inside of this while loop. And in this while loop, what I am going to do? I am going to do just sum is equal to sum plus sj. Okay. Now, okay, for more clarity, let me take m is equal to 4 or m is equal to 3 and you will get it. I know I'm just wasting time. Everybody could have figure this out why I've written this. So let's say when m is equal to 3 and when I is equal to 0, so for I is equal to 0, what is the consecutive 3 boxes would be? Index 1, 0, 1 and 2, 0, 1 and 2. So I have to go, means with j I am moving, j should move from 1 and 2. J should move from 1 and 2. So j is equal to, I have taken j is equals to I plus 1, so j becomes equal to 1. Next statement is, means I am going to do j plus plus here at the end of this, maybe the last statement of while. So because of j plus plus, j will become 2. Okay, now the moment j becomes 2, now I plus m minus 1 will be what? I is still 0. I is 0 plus m is 2. I is 0 plus m is 3. 3 minus 1 is 2. 2. So j is 2 and the condition is becoming true, so it will again go here. But next time j becomes 3 and so the condition will be false. Okay, that's why I have added this and this condition so as to incorporate the constraint that the consecutive boxes, the number of consecutive boxes do not exceed m. Okay, so this is j plus plus. Now what I can do is, now how you would have come out of while loop when either your sum becomes equal to d or it becomes greater than d. So if your sum is equal to d, then I am going to increase my count, right? Okay, but it might also be possible that your sum is still less than d, but your j has exceeded the limit of m consecutive box. It is also possible that sum is less than d, means this situation is true, but this situation becomes false, right? I will only increase my count in the scenario when the consecutive boxes, length of consecutive boxes is equal to I plus m minus 1, or simply say it is equal to m, and means the number of squares is equal to m. Okay, and the sum is equal to birth date. In that scenario only I am going to increment my count. Okay, so that's it. This is the code for. Let's go to the VS Code and let's run the code. Okay, thank you.
I'm done with that. Chapter 2. The end.